Steps for solving kinematics. Split it into components.
In a 2D kinematic, the first step is to split it into components.
Whoa!
X and Y components.
Step 2. Write down what you have. Write down. Write down what you have.
She's writing down what she has.
Remember that acceleration in the y direction is gravity, or negative 9.8 meters per second squared.
Gravity has a constant acceleration. Oh wow! And the acceleration of gravity is 9.8 meters per second squared.
And now it's time for...
Hi out there, it's me.
John and Ashley.
Have you seen Blue, my puppy? Oh, come on in.
I found one of Blue's clues. Look. There it is. Whoa. D equals V1t plus half AT squared.
D equals V1t plus half AT squared.
And we're going.
Look, I see one!
Whoa!
Clue!
Oh my god!
Look at it!
Where'd you see it at?
It's in here!
Oh my god!
Gosh!
Good eye, Ashley!
V2 equals V1 plus AT!
Who'd have thought?
V2 equals V1 plus AT.
Look, I found one! There it is!
You see it?
Yeah, it's right there.
Let's
Come on.
go!
Hey, you can't climb faster than me. It's right here. Look,
Oh wow, good eye, John!
look. D equals half parenthesis V1 plus V2 in parenthesis T.
Whoa! Well, what do we have so far?
D equals 1/2 parenthesis V1 plus V2 in parenthesis T.
Well, we found 3 clues, but I don't know where to look anymore.
Wait a second. It's
Mail time.
Mail's here.
Here's the mail, it never fails. It makes me want to wag my tail. When it comes, I want to wail.
Let's go! Mail time! Come on, let's go!
Oh my god.
Mail game! Let's go!
Oh my god, Ashley. That thing slung back so fast. Mail time has never gone so wrong.
Oh, look at all this junk. Oh, whatever. Oops.
Ooh.
Ooh.
Hey, that's to Blue.
To Blue.
Blue, aren't you happy?
Let's open it and see what it is. Oh my gosh! It's another clue. V2 squared equals V1 squared plus 2AD.
Whoa!
Whoa!
We got all 4 clues. We have D equals V1t plus 1/2 AT squared. We have V2 equals V1 plus AT. D equals 1/2 parenthesis V1 plus V2 in parenthesis T. And V2 squared equals V1 squared plus 2AD. Now we know. Let me get a video there.
Kinematics.
And that was
Blue's Clues.
So this is our all or nothing quiz problem. It's pretty great. Pretty great.
Kinematics.
Kinematics. All right. Okay, so we have a ball of mass 0.7 kilograms initially at rest, and it's kicked toward a fence. That's the ball. Yep, it's kicked toward a fence 30 meters away, as shown above. So that's 30 meters. And the velocity of the ball as it leaves the kicker's foot is 22 meters per second at an angle of 37 degrees. And the fence is 3 meters high, and the ball hits nothing in flight. Oh, I can't read that fast. Okay, so we're just gonna read.
Air resistance is negligible.
Thank you, John. So now for part A, we're going to find the initial velocity in the x and y direction. So we're going to draw our little diagram of what's happening. So that's the 37 degrees that the ball is going to go, and that's the velocity in the diagonal direction upwards that it goes. So that's the way that it's actually going.
She just redrew her picture. Is all she did.
It was important. It was important. So that is the velocity in the x direction, and that's the velocity in the y direction because we're splitting it into the two parts. So we're going to do the sine. Remember this trigonometry. Sine 37 equals, nice zoom. Whoa. V1 over 22. So remember that sine equals opposite over hypotenuse. And so V1y equals 22 sine 37. And that's 13.2 meters. So remember that sine of the angle is going to be for the velocity of the y. And then for the velocity in the x direction, you just have to do cosine. So just remember that sine goes with y, cosine x. Sine y, cosine with x. So you're going to do the same equation, but just with the v1x with the same numbers. So you're going to do v1x equals 22 cosine 37, and that is 17.6 meters. Woo!
Alright, so in the next problem, we're determining the time it takes for the ball to reach its highest point. That's the y value. So, okay, we're still explaining. We're still explaining the first problem, but we're
just remember, it's going in the two different directions. That we're splitting its 22 meters per second into the diagonal of the y and x.
Okay, in the next problem, we're determining the time it takes for the ball to reach its highest point. That's in the y direction, of course. Splitting the values. Alright, yeah, that's the height. The maximum height is right there. So we're drawing the y for you visual. So we're splitting it into two parts, the y and the x.
No, we're not.
Yes, we are too.
No, we're not. We're just
fine. We're just doing the y. It's a 1D kinematic. Whatever. V1 is equal to 13.2. V2 is equal to 0. 13.2 is from the previous problem. We showed what V1, the initial speed in the y direction was.
So V2 is 0 because it's at its highest point, so it's not moving right then. That's where it stops moving.
The acceleration of gravity is negative 9.8, which is why the acceleration is negative 9.8.
Good job.
So
remember, we're writing down what we have. Writing down what we have. That's what we have.
Okay, so we're looking for time. Time is a question mark in the y direction. V2 is equal to V1 plus AT, our equation we found on that was one of our clues.
It's one of our clues.
Alright, so V2 is 0, is equal to the original velocity, which is 13.2, plus negative 9.8 gravity, then T, time.
And you solve for it.
We solve for time, and we solved, and it is now T equals 1.35 seconds.
So now for the time for the ball to reach the plane of the fence.
Doing that.
So now it's
Alright, so we got some new hats.
Okay, so now we're going to determine the time it takes for the ball to reach the plane of the fence. So we took the time it was for its highest point, and now we're going to take the time to actually go the 30 meters to the plane of the fence. So we don't care about the height, just the x. So since we're dealing with the x, as John is moving the camera, we're going to make this an x column for our components. So V1 equals the initial velocity that we got from part A, so it's 17.6, and then A equals 30, which is the D equals 30, which is the 30 meters in the x direction, A equals 0 because it's a constant velocity. We're not accelerating in the x direction. It's only in the y direction that had the gravity of acceleration, and since we don't care about y, we're just doing with x. So there's nothing. Hooray. And t is also the question mark again. So the formula that uses VD, A, and T is D equals V1 plus
V1T
plus
plus
1/2 AT squared. So now you just plug in all your stuff. So we got 30 plus 17.6 T, because we're solving for T. So acceleration is 0, so you don't have to write this part just to show you what we're doing. That whole thing cancels since it's 0. So we don't even need that. It's just 30 equals 17.6 T. So we solve for T, and T equals 1.7.
Alright, time for part D. Actually,
It's time for a snack, I think.
time for snacks.
Time for snack.
Alright. Alright, so it is our snack time.
Snack time!
What'd you get for your snack, Ashley?
My snack is a 40-ounce jar of peanut butter. You know,
My
it's pretty
snack
good.
is Louisiana hot sauce.
John, gross.
Hey, you're gonna try it.
I'm not eating it.
You are trying my
I'm
snack.
eating my snack, thank you.
Alright, so I'm gonna eat this hot sauce.
You have to give some facts like Mr. McCarg does.
Alright, so what you don't know about Louisiana hot sauce is it's actually made in Louisiana. And it's actually not very hot. It's a pretty cold snack. And that's pretty much all I have to say about my hot sauce.
Alright. Well, I have my peanut butter, and it's pretty good on things like, you know, bread and sandwiches, but it's also good. What most people don't know is
It's also good
on
with Louisiana
spoons.
hot sauce.
No. You can have your snack. This will be my snack.
Alright, guys. Time to... that's how I hot sauce.
Let's eat my peanut butter.
Actually, it's a little tingly.
Oh no, really? It's hot sauce. Getting you ready. Wait. Oh, my bad. Wait.
What?
We didn't do part C.
Yeah, we did.
Oh, then I'm about to write this thing.
It's useless. You already said it was useless.
Okay, then I'm going to explain that it's useless. Okay.
No, I skipped it.
Okay.
It's just gonna appear. Okay, ready?
Explain how that is just a preview for this.
Okay, so that Y thing that we put down with Y and we did the Y component, that's just a preview for the D portion, which is, will the ball hit the fence? If so, how far below the top of the fence will it hit? If not, how far above the top of the fence will it pass?
Good question.
I hope it hits the fence so we don't have to calculate how much it passes by. That made me happy.
You're missing it.
Alright, stuff's going down. Okay, in the Y component, V1 equals 13.2. Acceleration is negative 9.8. Time is 1.7. D is the question. So, right now we're trying to solve for D in the Y direction. So D equals V1T plus half AT squared. D is 13.2, which is the V1, and the time is 1.7, as we solved in the last equation with Ashley. Plus 1/2 negative 9.8, which is gravity, times 1.7 squared. Alright, so we're solving for it. D is equal to 8.28 meters.
And the fence is 3 meters high.
So it's going to go over the fence by, what is that, 5.28? There we go. Look at that.
Nice math skills.
Pro maneuver. Okay, let's get more camera on you. 5.28 meters over the fence.
Alright, last part. Almost done. Okay.
Ashley, just start writing. Come on.
I'm explaining. So how fast will the ball be traveling when it gets to the plane of the fence? So this we're going to need both our x and our y components. So we're going to write the x components first. So v1 equals 17.6, which is still that velocity from the very first equation. D is 30, because in the x direction it goes 30 meters. A is 0, because it's a constant velocity, so it's not accelerating. And we're trying to find v2, because that'll be the velocity when it gets to the plane of the fence.
I can take a little shot of it.
Stop it. So our equation will be v2 squared equals v1 squared plus 2ad. That's the one that uses all the things we have. And we plug it in. It'll be v2 squared equals 17.6 squared plus 2 times 0 times 30. And so we can pretty much just cross that last part off because acceleration is 0. So v2 squared equals 17.6 squared, so v2 is just 17.6. Now that's just v2 in the x direction, and we need to know how fast the ball will be traveling. And so when the ball is traveling, it has x and y velocities for both. So now we're going to do our y component. So v1 equals 13.2, which is from the first equation. Acceleration of gravity is negative 9.8. Y will always be negative 9.8. T is 1.7 because that's what we got from the one before it, the time. And then v2 is the question mark again. So we're going to do not the same equation because we don't have distance. Instead, we have time. So we'll do v2 equals 13.2 plus a negative 9.8 times 1.7. So then v2y will be negative 3.46 meters per second. So we have those two. We have the vx and the vy. So that's the separate components. So now we have to combine the components, and we can do that with making a triangle of our components that we have.
New hats.
New hats. Last part. Okay.
All right.
So that is our little representation of the two components that we have. We have the v2 and x and v2 and y. And so we're going to make a little triangle of it to show, because that little dotted line is where the ball is actually going, well, with the velocities. So we're going to make our little triangle in the x and y components, and it's a right triangle, so we can use Pythagorean theorem to find c, which is that little dotted line. Do you like my turkey yet?
Yes.
Thanks.
What the? Oh.
Yeah, get on
I
get
forgot
on
I did that.
task. Get on task.
5.28 meters over the fence was from our previous
We
problem.
don't.
Hey, well, you're taking forever to get to the next thing, so we might as well leave some in between time. Yeah, the paper and stuff's going down.
Okay.
All right, she's writing now. You're good.
So that's C. So we're gonna do, a squared plus b squared equals c squared, so we can find. So that is the, that's the component of the two x and y combined. Since that's what we need, since the ball moves in both directions, we're doing both.
Yep.
So c equals the square root of 17.6 squared plus 3.4 squared.
It's equal to. Oh, there we go.
So that's c. So that is the answer, but to give that, we have to tell it at what angle it's at, because that's what we need to know.
I'm not really sure we do need to know that.
We need to know that. So once we found c, we're going to find theta, which is right there. And to find theta, we have the three sides, so we can do tan inverse. That's what we're going to do. So theta equals tan inverse, and the inverse, of tan is the way to find angles. And so we'll do 3.46 over 17.6.
And we're going to find
11.212 degrees. And so since it's going down, we know it's below. So 17.94 meters per second is the velocity. And then in our little brackets, we'll put 0.12 degrees below the horizontal. And that can show us the angle and the speed. So you need both. They're both important. Alright.
That was our video.
And that's our video.
Yay.